Okay, I think we can start now. Assalamu alaikum. Good morning, evening, afternoon to everyone who joined us on the third webinar for the Clean Energy for Africa webinar series. I'm really glad that we have a good amount of people this time. My name is Elhaj from the Clean Energy for Africa Initiative, and the Clean Energy for Africa Initiative is an educational initiative that aims to create a platform for students, researchers, and professionals to increase their capacity, knowledge, and share their thoughts and interests on renewable energy technologies, particularly focusing on African content and the needs for Africa as a continent as a whole. So today, or tonight rather, we're very glad to be hosting Dr. Hazir Farouk Elhaj from Sudan University of Science and Technology, who will be speaking to us about rolling out of small-scale biogas in Africa. I'm going to give a brief biography or introduction about our speaker. Dr. Hazir graduated with a degree in mechanical engineering from Sudan University of Science and Technology. Then she did her MSc at the University of Technology Malaysia, UTM, on advanced manufacturing technology, and did her PhD in biofuels at Sudan University of Science and Technology and UTM Malaysia. Currently, she's an associate professor at Sudan University of Science and Technology. In 2014, she was nominated by the World Bioenergy Association to become their voice in promoting the sustainable use of biomass in Sudan and the region of North Africa. This role opened for her an opportunity for international level of communication with people with expertise in this sector, and gave her a chance to improve her understanding of the current developments and to select the best development approach that suits the community in Sudan. Since then, she was and still is active in Sudan in promoting the development of bioenergy technologies as part of the way that Sudan can reduce reliance on fossil fuels for power production and transport, and also for alternatives for buying wood and charcoal for cooking in the rural households. She worked with numerous researchers, policymakers, non-governmental organizations, and private sector, including leading research projects, coordinating and chairing many initiatives and workshops, writing and co-authoring a number of papers and reports, preparing business cases and feasibility studies, and drafting roadmaps and reform plans for policy makers. These were all on various aspects of biofuels, biogas production, and waste to energy for Khartoum state, and general options for bioenergy development in Sudan. As a result, in 2018, she was awarded the prestigious TWAS Samira Omar Innovation for Sustainability Prize in Trieste as an outstanding woman scientist working in the field of sustainability within the world's 47 least developed countries. When asked why is she passionate about bioenergy, Dr. Hazir says, "Every time I fly to Europe and see the effective utilization of different types of waste by turning them into energy, I recall some scenes from my country, the high volume of waste produced by different communities and industries, the daily struggle of women and children to collect wood for cooking, the hundreds of villages which are not connected to the main electricity grid, and the thousands of graduates who do not have jobs or who are working in low-income ones." So this is a brief introduction overview about our speaker. I will also be sharing during the presentation at the end the link to her profile in ResearchGate and Google Scholar for anyone who's interested in learning more about her publications. So without further ado, before I give the floor to Dr. Hazir, can everyone please make sure you mute your mic? Musaddiq, I think your mic is turned on. If you can just mute it so that you don't have any interference. Yeah. Okay, thank you, everyone. Dr. Hazir, the floor is all yours now.
Okay, thank you, Dr. Muhammad, for this introduction, and I welcome all of you. So, assalamu alaikum wa rahmatullahi wa barakatuh. Good evening, good afternoon, good day for everyone. And I'm happy to share with you this session or this webinar about rolling out of small-scale biogas in Africa. I'm going to focus in Sudan because I will share my experience in promoting sustainable use of biomass mainly in Sudan. But as Mohammed say, as a board member in the WBA, I have a responsibility to promote this also in North Africa. So I'm not going to share any technical things about biogas, but rather I'm going to share our perspective and our approach to promote this in Sudan. And before that, maybe first I show my presentation outline. So I'm going to give an introduction and also show the drivers.
Can you play the presentation full screen? You just go to slideshow and yes, okay, thank you. Yes, thank you very much.
Okay, welcome. Okay, so I'm going to share the drivers for biogas and the potential, and also some applied experience of biogas in Africa, different countries, and show the status of Sudan and our role as academia or researchers, and show what we have done with my research group. And at the end, lesson learned from our experience are going to be requirement for successful program. So why is the development of biogas? Actually, I'm a mechanical engineer, and my PhD was in biofuels, producing biodiesel and biofuels and testing internal combustion engine. But I finished in 2013. But in 2014, I went to the first trip to Sweden to attend the WBA conference, World Bioenergy Conference, and then I was very inspired by the Swedish experience in biogas. So from the airport to the city where the conference was, the regional cities, the biogas buses was running in, the buses were running in biogas. And in the field trip, we went to the biogas plant where a group of farmers, like entrepreneurs, they collect the cow dung from different farms and brings to the biogas plant, and they produce biogas. They upgrade this biogas to be fuel for the station, for the cars, and they also have a certified organic fertilizer. And I was thinking, Sweden, with all the population in Sweden, it may be less than people in Khartoum, the capital of Sudan. So we have a lot of waste. We have a lot of the most or the bigger livestock in the continent, and also we have many other things needs that we should do this. And then I was thinking, why we are not having this in Sudan, and why it's also we are not having it in Africa in large scale for commercial. We still suffering from many things that this could be a solution, and also it could be not only for producing energy, but also for waste management and creating job and other things. So I shift my career to work in biogas and trying to see what I can contribute. Because in 2013, when I selected to be in the WBA, then I had the responsibility to promote the sustainable use of biomass. And this was one area that I should work in. So the first thing I looked at the experience of biogas in Africa. And I think most of you know the Africa Biogas Partnership Program, which created in 2009, which is public-private partnership between the national government in the country, and also with other organizations in Netherlands, like SMV, which is famous as a technical advisor for doing this in West and East Africa, and also the government of Netherlands in mainly the Ministry of Foreign Affairs. So they established Kenya Biogas Program, and Tanzania Domestic Biogas Program, and National Biogas Program in Ethiopia, and National Program of Biodigester of Burkina Faso. And they have a lot of successful stories, and they installed many different biodigesters to produce biogas, mainly for household and for rural areas, and maybe thousands of them are working now. There was also a national domestic biogas program in Cameroon, also supported by SMB, and there is a national domestic biogas program in Rwanda, which is established in 2007. And also there is different initiatives in South Africa, Zambia, Sudan, and many other countries in Africa. So the targets of biogas program were mainly contributing to the government's effort to deliver to commitments for climate change mitigation and sustainable development goal 7. As we know, renewable energy, affordable clean energy for all is the sustainable development goal number 7, and bioenergy is one of the renewable energy sectors. The other thing is providing a sustainable and clean source of energy, and particularly for women and children while boosting food security. And we will see later why, how biogas program can boost the food security. And also improving agricultural productivity by using the bioslurry or the biofertilizer, which is produced as the second product in the biodigester, and also reducing deforestation, because cooking with biogas will eliminate cutting of wood fuel in different countries, which is famous in Africa, and also improving health and livelihood, and we will see later how this can be achieved. So the main type of biogas digesters used in Africa, yes, the fixed dome, the Chinese fixed dome one, which in the left is a famous one, but there were also many other biodigesters, like the one in the photos, the 3 photos, which we call it the balloon one, and also from the fiberglass, and also different types that suit the country, and always the companies and the organization like SMV trying to make the biodigester is part of the community. So it is what is available from the materials that are available in the country. But these are the famous designs they are used. And this is also another type of underground Chinese design in Zambia, and the left photos, different designs, but at the end doing the same job. And also this one in Tanzania. The application of biogas are mainly for cooking with biogas, as we can see in the photos, and also for using biogas lamp. Sometimes the biogas is not enough for cooking, only for cooking. So some people look for other solution for lighting, but at the end we can use the biogas for both lighting and also for cooking. And the benefit of biofertilizer or bioslurry can be used to promote home gardening and also increase the crop yield at different levels. So I'm going to share some experience from of biogas. This one from Kenya, and this man is using the balloon, what you call it flex bag biogas. Actually, the design is originally from Rwanda. They produce the biogas in their farm from food waste and also from agricultural waste in their farm, and they compress this biogas using the compressor in the photo, and they sell some of the biogas compressed to the families as instead of LPG, and some of it they using it as like fuel for rickshaw, as in the photo also. This is another type which is in a slaughterhouse in Kenya also. It's a very successful story. We went and visited this plant. It is a big one. They are using the waste of the slaughterhouse using in biodigester, which is the photo with the red and green. It is a Chinese also underground one, and so they use this to compress biogas. So they developed these compressors in the left. This compressor is designed by them, and if you can see, this is small LPG. This is small unit of LPG, or what do you call it? Okay, they distribute this LPG for neighborhood, like community responsibility, because the slaughterhouse is big. And also they are using it inside the slaughterhouse to produce electricity with this generator at the right hand. So what is the case in Sudan? The very thing that we went for to understand what is the situation in Sudan. So the current situation in Sudan after 2011, the separation from South and the North, we turned from countries that was importing petroleum fuels to countries that exporting petroleum fuels. And so we had shortfalls in domestic supply of petroleum product. And as we can see this in the figure, this figure from like 2016 and now it is more. So we have lost a lot of petroleum products we are importing. The LPG is now more than 42% shortage. So we are exporting, and we use this. We are using this mainly in the big cities. So the rural areas are suffering from not having access to LPG, especially Sudan is a big country, and rural areas LPG cannot reach rural areas. Now we are facing, even in the big cities like Khartoum, people are queuing to get access to LPG. We having also increasing in population growth. So the annual change in population growth is 2.4%, which means the needs are increasing. And we have very fragile economic conditions to provide, like foreign currency to export more petroleum products and blah, blah, blah. So we need to like having options that for self-sufficiency in the country. And this status also can be applied in many other countries in some degree in African continent. We also, most of people of rural areas are without access to LPG, as I said, and electricity. The electrification rate in Sudan is less than 40%, with 70% in big cities. And as we can see in the photos, in Sudan, in many African countries, the woman is not only responsible of cooking, but also for providing the fuel for cooking. So women and girls are going to far places just to cut full wood fuel for cooking. And then they are cooking in very bad environment. So this group of women are cooking in the normal cooking process in Africa, which is 3 stones, but this one is outdoor. But normally it is indoor, which provide very bad environment for women and children also who are around the women. So cooking with biogas can save time and provide healthy cooking environment. As you can see, these 2 burners are from biogas, and so it will be like a good solution that solve many problems. The other thing is that Sudan is also suffering from high deforestation rate, 2.2% per year, from using up to or more than 30 million cubic meter per year of fuel wood. And these photos are from different parts in Sudan, from the north and also from the middle of Sudan, and also from the east of Sudan. So how we can expect these areas will be in like 20 or 50 years later. So what was our approach? The very thing that we have done in late 2014, early 2015, that we called for a stakeholder consultation workshop. So we tried to understand why there is no development of biogas program in Sudan. So we brought all people that have done any activity in biogas, from like academia, from the research institute, from private sector, and also from if there is any companies that produce installing biogas units. And we found just one company that started in Sudan in like 1980. So in this stakeholder consultation workshop, the main objective was to understand the barriers and prioritize the needs for developing biogas in Sudan. So we should have the need and we should have the potential to start this program. So in this, after this stakeholder consultation workshop, we established our biogas research group. It is formally formed and sponsored by the Deanship of Scientific Research in Sudan University of Science and Technology. So the second thing is to build real models and tell successful stories. So why? Because one of the things that we come out from the workshop is that people are not aware about the potential of biogas. So some cannot believe that we can get biogas for cooking from waste, like any organic waste like cow dung, or from food waste or like this. There is no biogas units working, even they installed since 1980 in different scales from 3 cubic meter to 25 cubic meter in schools, in prisons, but they were all not working. The other thing, there is no capacity for people to install or to maintain. We found just one company and one person who passed away last year, rahimahullah. He was the one who is installing this biogas digester since 1980, and mainly where the installation was for the Chinese fixed dome, the underground one. So we asked our deanship, our vice chancellor, sorry, to help us and finance the installation of one unit, so we use it for awareness and also use it for research. So in this photo, you can see this very fancy and very proud of this biogas unit, which was installed in early 2015 in the Faculty of Agriculture Studies at Sudan University of Science and Technology. It was 12 cubic meter fixed dome digesters with gas holders, as you can see, and two reserve for the bio slurry. So this the two youth men were from the biogas research group, and because we selected this area because the College of Agriculture Studies has a small farm which have so the feedstock is available. So it was mainly used for promoting and also for research. The other model that we built in 2017, because the first one, sorry, I will go back to the last slide. This model was built, but the cost was very high. It was really high because the cement, the labor, all this stuff will increase the cost. So to promote the technology, we wanted to have like cost-effective models. So this was made by engineer Faisal rahimahullah, and then they later in 2017 he promoted this like similarly to flexi bag. He like this one is 2 cubic meter. We installed in our Faculty of Engineering, and we also had like a small area to test the bioslurry and see its impact on the yield of the vegetables, as you can see in the photo. And also we tried to see the impact of different feedstock, like we tried cow dung, and also we tried mix of cow dung and slaughterhouse, and also we tried food waste available in the cafeteria of at the university, different feedstock. So we tried also to see the pressure of the gas at different level and different temperatures. So it was like we want to ensure that if this model, it was cheaper, but is it going to be or to have the positive impact on the family? This 2 cubic meter biogas digester was also installed in Engineer Faisal rahimahullah house. So we were sharing the information, as you can see, for example, kind of meal, cooking time, initial pressure, and all this. So just to evaluate and see and do proper research. Then we try to do our research, and our research, because we built these small models, and another thing that we are proud of, that we have our own biogas research lab. And this biogas research lab was not only for doing research, but was also to help other researchers from other universities and other research institutions to come and do their research and understand how they can fabricate different models. So we started with this one, and later we developed this one because we wanted to create solutions that are part of the community daily life, culture, and their usual business. So mainly to avoid resistant chicken. So this biogas unit in the photo was made mainly from water tank available in Sudan. We use 250 cubic meter. We did all the, after we finish our experiment in the lab scale, we turned to this one with the research group, and we found it very good and useful to produce amount of gas. Yes, it is not enough for household, but we can enlarge the scale. We wanted to make sure the material and the fittings are fine, and the product, the biogas and the bioslurry and everything is going fine, and also the safety of the unit. So we have done this at this scale. Later we turned to 1 cubic meter, and 1 cubic meter was enough to produce like 1.5 cubic meter per day. So we found that it will help in cooking, because cooking with biogas, it depends on the meals that you are cooking. For example, if you are cooking this heavy porridge and other things that famous in Africa, it will be, for example, need many hours, so a lot of biogas. But the biogas may be not enough for lighting, so we have to look for a solution for this, and this we are going to see in the recommendation. So the other thing that we have done, we not only working in the units in the lab, but also we try to promote the development of strategies for communication with different stakeholders and build the trust. These kids in the photo were in the east of Sudan, and the biogas unit, this one is like flexi bag, yeah, the green one was installed there, and they were all sitting thinking this could be a nuclear bomb, something dangerous. So they cannot believe, they didn't believe that this can produce biogas, and this biogas can be used for cooking. So how to bridge the gap between the scientists and the companies who are promoting this and the people in rural areas, because at the end they want something they used to cow dung. They can produce pellets from cow dung and use it as charcoal. Okay, so how to convince them with biogas? We need also to develop strategies before starting any biogas program. The fifth thing that we also, it was one of our perspective, is to not work from scratch, is to work in partnership, national and international. So this is our ex-vice president of WBA from Australia, and he used to come like 4 times to Sudan just to help us to move things in bioenergy. And so he was explaining to the research group different parameters, different designs, and how the things that we have to consider in our design and in our promotion process. And by connecting with him, we were able to be connected with many other people working in the development of biogas and in the technical aspect, especially, for example, from SMB and also from GIZ and also from HEVOS and also from other organizations promoting biogas in different countries. The sixth thing that we also try to work in is to bridge the gap with between other stakeholders and create sustainable relation and early involvement of them. Because, for example, we found that from the experience of biogas since 1980, biogas units were established by like donation. So, for example, NGO, international or national, come to the area, they install the biogas work for 1 month, 2 months, and they go. Then it is free. If something happened, you need maintenance, no one knows how to maintain. The people are not aware of how, or it is complicated. The people are not committed because they are not paying. So if this work, it doesn't work. So they are not going to look for any solutions that will cost them. So they go back to their usual business, like cutting wood fuel or anything else. So we want them to have like early involvement, and the early involvement, we try to conduct national seminars and forums in different states. For example, for people in Khartoum and also for people in the states, with people in the government, and also try to link with the linkage with people in NGOs, because they are more better than us in promoting, and they know the language and they can talk with the people in rural areas. And also we try to make or conduct capacity building programs, trying to get money from government, from private sectors, and build this program for training, make exhibitions, study visits, and write papers in different language, and Arabic, for example, and also in English, fact sheet, business models, and everything. So these all were just to bridge the gap between stakeholders. And I think from 2014 until now, as awareness is better, it's more better than first, and the commitment to have really establishment of this program is more, and people and researchers are working in different designs using the local material, because always and appropriate technology as well. So always solution coming from outside need to be customized based on the community needs, and also what are the potential of material and other things. So I wanted to make or to put the applied experience of biogas in Sudan in the last slides. So up to now, there is more than 200 digesters from different designs. And one of the initiatives that done is by Professor Muna Mahjoub from Institute of Environmental Studies. She initiated and managed the construction of 10 household biogas units in Western Kordofan, mainly installed by Engineer Faisal, rahimahullah. This was in 2014 and funded by Hazir company. And later in 2017, WFP funded the construction of 50 biogas units. The capacity was 10 cubic meters, and these were for different schools. And the objective was to provide cooking gas at the school, so they cook the meals and breakfast for the children at the schools. This was done in Darfur and in East Kordofan. So they went through different steps until they installed this. They done public consultation and selection of beneficiaries, because this was mainly for the 10 household biogas units, because they wanted to ensure that they have successful stories. The household biogas digester was fixed dome, the volume was about 3 cubic meter, as you can see in the photo, and mainly where the biogas was used in for cooking, as you can see in the photo, and also for lighting, as you can see in the photo. And the other thing is they use the biofertilizer to promote the home gardening in Western Kordofan. The 10 cubic meter, the 10 biodigesters installed there, and the people there were really happy. They improve the crop gardening, and also they promote the home gardening, because most of families in rural areas, they're having big areas as their houses, and these areas could be used for home gardening. So the water they are using for the in the biodigester, they can use the liquid fertilizer to grow to irrigate these vegetables. It will have impact on the family by providing food security, and also it can provide another income by selling this in the market or for the neighbors. So these photos are from Western Kordofan, and you can see how the crops improved. So in 2016, engineer Faisal, rahimahullah, in the middle photo, as I told you, installed 2 different plastic units, 2 cubic meter, at his home. And since then, he was using this biogas for cooking, and he don't have any cow or chicken at house, but he is using the food waste, and sometimes the neighbors bring their food waste and put outside the house, and so they later put in the digester. And sometimes also he used to go in the past to bring cow dung from the slaughterhouse and add to the digester. So if you can see, the blue one and the orange one is the vertical, and the horizontal, he was like comparing the fuel, sorry, the biogas produced. And in the right hand, this is in the kitchen, cooking different meals with biogas, the burner in the middle photo, and also for lighting, for the light in the house, in the right photo in the bottom. So to promote any biogas for household, the first question people used to ask us, what is the cost? What is the cost? And so directly they compare the cost of the unit with the cost they pay for LPG, for example, or for charcoal, or for cooking wood fuel. But this is not the case. The household should calculate many costs. So the first one is the cost of cooking fuel, total cost of wood, charcoal, LPG, kerosene, or cost of time to get the fuel. And the second thing is the cost of biogas digester. And the cost of biogas digester, yes, we're having the initial cost, but we have to look for the cost in the lifespan of the biodigester. So, for example, if the fixed dome biogas digesters last for 25 years, so I'm going to use it for 25 years. So I have to calculate the cost. And if I'm going to buy flexi biogas or the plastic one that I showed you in Engineer Faisal house, so it will last like for 10 to 15 years. So I have to calculate the cost based on this. And also the household need to calculate the time to repay the cost of biogas digester, because usually we say that we have to build a business model for the household. Maybe the front cost will be quite much, because we are talking about more than 250 US dollar. It could go up to 500 US dollar. Depends on the country, depends on many other things. So in doing this, it could be part of like microfinance program. So is the households going to pay the cost in 1 year, in 2 years, in 3 years? So this also should be calculated. The expected lifespan of the digester is also important, as I told or said in the beginning. Opportunity to increase vegetable production by using the fertilizer. Some people in households, they are not using the fertilizer for home gardening, but they sell this fertilizer. So it could also be another source of income. So this also should be considered. Saving on health treatments, because the cooking indoor with all this smoke will cost many health problems for women and also for children. So we should calculate this. An earning option for any extra time available. So if the woman is used to go to cut wood fuel, for example, spend like 5 hours, okay, and then come and cook. So she can save like 2, 3, 4 hours, and she can do many or other things that are more economic for the family. And also we can we have to calculate the better health that we are going to provide to the household people, the good lighting at night, and also the waste management that could be achieved by promoting biogas. So needs for development, and these are lessons learned. So appropriate technologies. So from Kenya experience, and also from Tanzania experience, and from Sudan experience, we need to integrate biogas for cooking with other renewable technologies. As I told you, when you produce a biogas, so how much feedstock you have? Is the water is available? Okay, and how much you are going to produce, and how much you need from the biogas to cook. How many hours are you cooking? 4 hours per day or 6 hours? Which type of meals? So it will based on this you will decide how much you need. So if the biogas is not enough or only enough for cooking, then you need another source for lighting. So to make the house self-sufficiency, biogas can be integrated with other renewable energy like solar PV for household and community and agriculture, and also battery storage system for a small scale solar PV and wind turbines in off-grid situations. Because sometimes for community-based project biogas, people can share the biogas unit. So instead of installing like 3 or 4 cubic meter biogas unit for one family, they can share one bigger biogas unit. So it is community one. Also in the farms, the biogas unit could be more bigger. So all these options should be looked for. Also, we talked about the use of biogas mainly for cooking and also for lighting, but biogas also for cooling and small-scale electrical generation in off-grid communities and for hospitals, for schools. This also could be options that could be adopted, and also development of simple fuel switching system for biogas, like small diesel power gensets that using biogas. So you are not using only diesel, but you are using biogas with diesel or biogas with benzene. And now in Sudan, we are facing a lot of challenges in providing sustainable flow of for diesel. And most of people in rural areas depend on diesel generators. So this could be an option. Development of simple fuel switching system, as I said, and low-cost clean cook stoves and biogas burners, because we want to low down the cost. So with this, all are opportunities for entrepreneurs to have like small setups. So some can work in developing biogas units, and some can work in developing low-cost clean cookstoves and biogas burners using the available materials in the country, in the community, and so they provide a solution. This will provide income and also will create more jobs. So lesson learned: requirements for successful program. As a core of a successful program for installation of a small scale biogas digester from 3 to 8 cubic meter, there is number of critically important requirements. The access to finance for the household through some microfinance system to provide low or zero interest loan to eligible applicants. For example, SMV, when they start program of biogas in Kenya or Burkina Faso or Ethiopia or in any other country, they will start in partnership with the national program. And one of the requirements is they should be like microfinance program. So they are not providing fully funded biogas digester to families, but rather they make the families or to be part of the solution, and the family should pay. But with the microfinance program, the cost will be like spread in 2 or 3 years or up to 5 years, and also it will be less because it could be supported by the government just to promote this, remove the subsidies and provide any reform like removing taxes also, just to help this moving. So this one thing. With any program, there should be a training process for masons and availability of fully trained people that know how to operate the biogas digesters and also to maintain the biogas digester. Because now most of the digesters that in Sudan closed because no one know or interested or has the capacity to maintain. Sometimes the problem is really small or minor, but at the end this is the case. And a well-designed promotion and marketing, and also full support and program by all stakeholders. So we cannot work without integration or completing with other stakeholders. We need the government to support with the policies, subsidies removal, tax removal, also initiate also, and to have the program, we need the private sectors, we need the NGOs, we need the researchers to come with innovative solutions. We need the communities that are going to benefit from this biogas. So all these things should be designed. So we need, and also the promotion and marketing should be like suit the community and suit the country. In Africa, we share the culture. The culture is most the same. So we can benefit from successful stories, especially in Kenya, Ethiopia, Tanzania, Burkina Faso, and others. And also, development of biogas program should be part of reducing deforestation. So we always having like RED++ having program to have more trees, to grow trees and keep the forest. So if we didn't provide solution for the people who are cutting the forest, they are going to cut the forest again. So the development of biogas program should be part of this program of reforestation. So they will have the fund and they will have the support and they will ensure the sustainability of these programs. And I wanted also to share with you this decision-making tool I found published by researchers from, I think, in Australia, but it was mainly targeting Sub-Saharan and based in the successful stories or biogas stories in Kenya and Cameroon. It was published in 2017, and it shows if you want to go to this any biogas program. So these things that you have to include or have to consider, sorry. So the decision model, the decision-making tool was to increase the awareness of potential of biogas technology for different applications in sub-Saharan Africa. And it shows the input, what are the priorities, the energy demand, the feedstock available, the amount of feedstocks, the type of feedstocks, the rate of supply to ensure the sustainability, the location details, because I want to ensure there is water supply, what is the climate, what is the soil type, there are groundwater availability in the area, the fertilizer demand, there is demand or not, the local construction materials, all this I need to consider and see as input. The economics, the income and saving, and also the avail of subsidies. Also they have to look for this before I start working in. So biogas required, the volume and quality, biogas production potential. I want to know how much cubic meter per day we are going to produce, because I need how much, and also the water supply and installation and heating requirements, because some areas are cold, some areas are very hot, and this will has impact on the, will have impact on the process of anaerobic digestion, and also the total funds available, and the subsidies is going to help or not going to help on all these things. And from this, we are going to have the suitable system size and design. Okay, we could have different designs based on the models, and there are many different designs, because SMV is working in Africa but also working in Asia, and there are many successful stories in Nepal, in Vietnam, in promoting the biogas digesters. And now in Vietnam, SMV is not constructing or installing, but people are installing their own biogas, because the know-how now is already in the as the community level. So this is the case. So we have just look at this decision making tool, and it will help you for those who are interested to build their own digesters, or to work in designing and having their own company. Myself, I really want to be part of a bigger program, and not only in promoting but also in designing, and I really hope to see a development of biogas in Sudan, like a national program like in Kenya, because now Kenya is moved from small scale to commercial scale, and they can produce, and I think most of rural areas, and they're using this, and they are aware of this, and thousands of biogas digester from different designs are installed, and also this is the case in Ethiopia. So just we come to the end. Let us innovate, and the innovation is not only in the designing, as I said, but also in promoting and in marketing. And this is our biogas digesters, biogas digester in Faculty of Agriculture Studies at Sudan University. And this is my daughter in 2015. And we are just comparing. This is the light. This is actually, this I didn't say that. This is digester, was also used to the biogas was used for lighting the poultry house in the which is big in the faculty, and also for heating the milk which produced in the near farm from the cows. There is many cows there, and so you can compare the electricity which was not available with the biogas which is lighting, and this was really really amazing at that time. And this innovation in biogas development not only like just a business or just to promote companies' products, but towards the 3 pillars of sustainability. So the environmental protections, because biogas is development of biogas program is part of waste management, and we all know how Africa is suffering from waste in different cities, big cities and small cities and rural areas. It also helps the social equity because it improves life of families, and also the economic viability. So biogas will bring energy self-sufficiency and also improve rural economics. I hope that I covered what you are expecting from me in this session or webinar. My email is biodieselgroup11@gmail.com. You are welcome to contact me for any further information and to share with you any documents, and also to exchange and work together in promoting and rolling out the small scale biogas in not only in Sudan but also in Africa. And I think by this I end my presentation, and if you have any question, you are welcome.
Okay, thank you very much, Dr. Hazir. Great presentation, mashallah. I think most of us were overwhelmed. A lot of data, a lot of facts, a lot of case studies, and I think you covered a number of topics in the area of biogas technology, the different applications, case studies, and I think it's also eye opener for a lot of us. A number of our are from Sudan, so I believe a lot of the things you mentioned, they gave us a clear idea that there's a big potential for this technology, which is still untapped. So I really appreciate the presentation, and thank you very much for your time. We will open the floor now for any questions from the audience. So if you'd like to ask a question, please unmute your mic and introduce yourself first, and then you can ask the question.
Assalamu alaikum. Assalamu alaikum. It's me actually, Muhammad Hassan, engineer Muhammad Hassan. I have been graduated in chemical engineering from University of Jazeera, and actually I was very interested about the renewable energy, especially the solar energy, and last years I was interested about the biogas. So thank you very much, Dr. Hazir. And I just want to ask about one thing, about the safety issue about this system, because this is a gas system, and you know the system under the pressure and temperature, and there should be some safety issues. So to control the pressure for these vessels or these tanks, if there is any hazard, or if there is any safety problem. I don't know if my question is clear or not.
Yeah, it is clear.
Okay.
Yeah, maybe I will collect all the questions and then answer.
Okay, thank you.
Okay, thank you for the question.
Okay, do we have any other questions from the attendees?
Yes.
Assalamu alaikum.
Thank you very much. Okay, go ahead. Somebody else wants to say a question. Go ahead.
Assalamu alaikum. My name is Mohammed Mahjoub, chemical engineering, University of Imam Mahdi. This question is water supply. What is projector and anything by
Mohammed, maybe sorry, I didn't hear your question. Can you repeat?
what production to water supply and introduction to water supply.
You mean the production of biogas from water, or I didn't get you? I didn't get you.
Water.
Dr. Muhammad, maybe did you understand?
Engineer Muhammad Mahjoub, I also think the question was not clear, but you can try to write the question in the chat, so as text, and then we can collect it, because the question was not clear. I heard the word water, production of water, something, but it was not a clear question. So maybe you can write it in the comments, Muhammad.
Okay, no problem.
السلام عليكم.
وعليكم السلام ورحمة الله وبركاته.
I am Halim Farouk from University of Khartoum. Actually, I'm a lecturer of English language. So I have a question. Okay, can we implement these bioenergy projects on local basis? I mean, can we implement them at homes? Can we create our own projects to produce bioenergy? And is it safe or harm? Thank you.
Thank you, Dr. Halim. Musaddiq, I think you wanted to ask a question.
Yes, thanks a lot, Dr. Hazir, for all that presentation. I mean, it's very informative, and we've learned a lot out of it. And I think you've mentioned the implementation or the usage of biogas at the buses in Sweden. I myself, I'm living here in Sweden, and it's really amazing to see how much Sweden and the European countries are using such a renewable energy in that form, and at the national level, of course. And my question is, how much involvement or how much was the government involved to promote such a technology? I mean, using biogas. And from your experience on the past and current experience, and the experience, of course, from the neighboring countries, Kenya and Ethiopia, when do you think in Sudan at least, or maybe other different African countries, we could be reaching to that national level of biogas usage? And another question, just by the side, of course, we're just talking about biogas, but is the biodiesel, has it been touched upon, or perhaps in the future plan of your in the university or at the national level, do you think? Those two questions.
Okay, do we have any other questions? Dr. Hazir, I just saw another question from Engineer Muhammad Mahjoub. He says, what are the technology projects in supplies and how they can be applied in Sudan, and the extent of application of smart supplies to rural villages? I'm not sure is smart supplies. I'm not sure if I understand this correctly, Dr. Hazir, if you can.
I really didn't understand the question, because he's talking about the water supply. I'm not sure.
Muhammad, yeah, it's not clear. So if you can try to rephrase it. There's another question from Abu Abdullah. He says, what about the funding initiatives to implement the same? I think he means to implement biogas pilot projects like digesters and so on.
You mean fund availability or?
Yeah, he wrote funding initiatives to implement the same. So I guess to implement biogas digesters or small-scale projects, perhaps.
He's asking like if there is any fund initiatives for this or what?
Yeah.
In Sudan? Or?
I think so. Yeah, I think so. Yeah. Yeah.
Okay. Okay.
Muhammad Mahdoub is saying it's water supply.
Water supply. I think this is out of my scope.
Okay.
Maybe, but maybe if he mean because in this case I'm talking only about biogas produced for household, small scale. So the feedstock is mainly what is available in the household. So because biogas could be produced from any organic matter. So it could be produced at market levels from market waste like vegetables or from wastewater, also from human waste as the biggest level, because in Sudan, maybe in latest 19 or early 2000, we had 2 digesters, 25 cubic meter built from for kids that are reading Quran in Khalwa, mainly in Kordofan, in North Kordofan, and they were producing biogas from toilet waste. So, but in this, I didn't talk about this, yeah, because I'm talking about household scale.
Yeah, again, or actually, this is Engineer Muhammad Hassan, someone else. This is a different question from Engineer Muhammad Hassan. Is there any projects in Sudan producing biogas from wastewater? I mean, units attached to water treatment plants. So if you can.
Okay. So maybe I start replying this question. So we start with the first question from Engineer Muhammad, I think also about the safety issues. Yes, we have to consider the safety issues in the design. So the unit I told you that we built at our university with the research group was mainly from water tank, and so the material is the selection of material is one of the parameters in the design, and also to ensure the fittings. So we don't want to have any leakage of the biogas, okay? And also we want to ensure that we have the right pressures that we need, so we have the biogas in the burner or for the lighting. But if you produce biogas more than what you consume, so you will have more biogas. So you have to have like to consider valves that you open when the biogas reach certain level, then the extra biogas will just go out. And after you finish, you have to close your valves. You have to ensure that you don't smoke or have any fire near the area. But you just consider it in the design. When you design anything, you have to consider the safety things. I didn't talk about the technical things, but I can share with you our work and our papers, and you can find it in any publication about biogas in design, how they consider this and how they make it a safety. For example, when we're talking about rural areas, means that maybe you have kids around, you have like dog or chicken or goats around, so you have to protect your unit. So this all considered in the design and also in the implementation areas that you put your digester. And you also ask about the water supply, I think. No, this is the other question. Okay, Halim from Saudi Arabia yes, we can produce our own biogas. It's really simple, and I will be happy to share with you a link with big initiative. They just work in doing biogas as simple as possible, because we just want to have the anaerobic digestion. Maybe Halim, you don't know the process of biogas. The biogas is produced through the fermentation of any organic matter in a closed system. We don't want air, so we call it anaerobic digestion. So we don't want air to be in. We want to ensure the bacteria is growing and ensure the fermentation is developing in like stable condition. So we don't want a drop in the temperature, a high drop in the temperature, because the bacteria will die. We want to ensure that we have enough pressure to have the biogas to use it, and this is when they use the flex bag or the balloon one, they sometimes, if they don't have the pressure, they put a pressure on the unit, so just to ensure that this pressure is enough to have the flow of the biogas. So we can have it at home with house. You can have it with even very simple like the water tank. Just make sure that what you need or the system you develop at house, ensure your fittings, consider your safety, and ensure that you have this sustainable supply of feedstock and the water, and also it is enough to produce for you the biogas that you need for your application. If it is for cooking only or this for lighting as well. I can teach you this more. Halim is my sister, Dr. Muhammad. So Musaddaq, welcome I welcome you because I know that you just had your iftar. So the government involvement, unfortunately, as usual in the third world countries, the government is always not there. In Sudan, the government is not there. I work with the government, and we try to promote this not just in small scale, but also in large scale. Because now the problem we are facing in Sudan, we having all this potential, and we having all these engineers, and we having all these resources, and people are queuing to have LPG with like more than 500 spent hours and doing this. As I showed you, some families now are depending on the biogas unit. Okay, like for example, like in Engineer Faisal Rahimullah, and he is in Khartoum, by the way, it is not in rural areas. The involvement of government is important, because with the policies that the program could be developed. For example, when I approached SMV, they had SMV conducting a biogas course, domestic biogas course every year in Germany. I went to their biogas course in 2015. Just as a part to understand the technical issues. So when I promote this, I understand what I'm promoting. And I approached them and I asked them why we don't have a national program in Sudan Bio. You establish many programs in different countries. And they said they're having like 5 requirements. The first thing is to have support from the government. So one of the ministries should be part of this. And also they said we should have a microfinance system, and we have the microfinance system in Sudan. It's it is mature and well established, but the involvement of government is not there. So we can, what we do is just initiatives. Even 50, 100, we are talking about million of digesters that could be established in Sudan. So the involvement of government is important. And this is what happened in Burkina Faso, in Tanzania, in Kenya, and also in Ethiopia. And this is why it become like national program. In Zambia, the same case. Some donors, some NGOs, national, international, make initiative, 10 biogas digesters, 20 biogas digesters for schools, but the sustainability is not there because there is no national program. In the national program, you have to have phases. And SMB, what they are doing, they start like working 5 years in the country. They give the know-how and everything to the community, and the community will run this program by itself in the coming years. So, and they just quit. Now SMBs, they don't have any fund or support from I think the Netherlands government, and so the national government should take care of them to come and do, for example, the assessment, the visibility, because they have to look for the many parameters as I showed in the decision model. And about the biodiesel, actually, I started when I did my PhD, and during my PhD, I worked a lot because I have done my PhD in biodiesel mainly because the government at that time in 2009 was established a program called National Program for Biofuels. And I wanted to do just my side, the research one, because they were promoting biodiesel from Jatrova, but unfortunately they were not following the roadmap, the real roadmap or the correct roadmap, and the project is failed. I didn't continue in the biodiesel because it requires a lot of support from the government. We cannot just, because we want to grow a lot of many areas, big areas. The subsidies should be there and many things, not like biogas program. The involvement is there, but less. So this is why I moved to this. And I really, you know that Sweden, Germany, and all these countries that you went to are just doing very well in promoting biogas. What are the fund initiatives? I didn't understand, but from my experience, we need fund to start, but not to continue. So always the related department in the government make their plans, and they are waiting for the fund. The fund is not coming to you. You have to work to the fund. You have to make your business model. You have to show, I'm having this, I need you to complete this, but we cannot just wait for the fund. For me, myself, I was paying from my pocket to make this happen. My friend Prof. Muna was paying from her pocket also to make these things happen, and after that she got the fund to have more digesters implemented. So you have to have the passion to do that, not just wait for the fund initiatives. Government should be involved. Government policies should support this by what? If they remove the subsidies or the taxes, so they will make it easy and make it more cheaper. Okay, they can support. Okay, and also so every stakeholder have the role to play in having a national program. And about project of wastewater, unfortunately, no, there is no any commercial or big project using wastewater. Most of the digesters implemented in Sudan from 2 cubic meter to 25 cubic meter. I think Engineer Faisal Rahimahullah have he implemented or installed a biogas digester in his family house in Madani in 1918, using the wastewater from I think from the toilet, but that was in household level. We also trying to promote this to people here in Sudan for wastewater, because now the wastewater treatment plant in Soba and also in Wadafia in Haj Yusuf are causing many environmental problems. So the need is there and the potential is there. Yes.
Is the technology much different when using liquid like waste as compared to solid waste for producing biogas? Like for example, using black water source instead of using.
the process of anaerobic digestion is the same, but maybe for using wastewater, we need, because we want to ensure that we're having the right yield. So the water, for example, I'm having water coming from household, wastewater coming from household, and wastewater coming from chemical plants or chemical industries. So this should be separated. Because if I want to use the filterizer at the end, I want to make sure the filterizer's structure is not harming to the environment and to the crops or to the people. This is one thing. The other thing, I want to ensure that I'm having the right yield of the biogas. So from the experience and what I learned from Engineer Faisal rahimahullah is that the wastewater need to be mixed with solid organic, like for example cow dung or for food waste. We were proposing, for example, for SOBA, the food waste coming from the central market in Khartoum could go to that plant and mix with the wastewater in the digester. And normally, when they are using digester in for wastewater, they used what they call it lagoon. The lagoon is like just the same idea of the flexi bag, but it's very big. Maybe I can show you in another photo. Just a moment. I hope I find it, but if not, maybe later I can share with you. So I hope I answer all the question. If anyone
we have a formal question in the comments from Engineer Mohammed Mahjoub. He asks about how effective is the use of goat waste in the production of biogas, and do plants produce
we need to mix
biogas or fertilizer?
Okay, I can share with you. There is, for example, for each feedstock, there is you have different yield. The food waste, when we mix it with slaughterhouse or mix it with cow dung, it gives more yield of biogas. So different feedstock have different yield of biogas. I can share with you these technical things. But if you use goats, for example, when we use, we try cow dung and chicken manure and food waste and slaughterhouse waste, and we found that chicken manure having, for example, more ammonia. So we need to do some treatment and mix with other feedstock before it goes to the digester. So if you're having like goat, so you can mix the dung of goats, but it is better to add some other feedstock like food waste. And when we say food waste, any organic waste. So if you potato, the shells of the potatoes, the shells of the onion, the shell of the banana, anything at household which goes to the trash, you can add to the digester. You just need to cut it fine for the fermentation, and then you add it to the digester. So all these technical things are available. It is all available. So it is not really big problem.
There's another question from Omar Hamza. He says, good day, my name is Omar Hamza, electrical engineer. Me and other engineers have done many studies to apply biogas and benefit from it financially in Sudan. When we reached studying the market, we have found that it is not feasible as a financial input due to the economic policies. Comparing the inputs to install a system by outputs are useless. When we compare them to the gas sold in the market, it's cheaper than biogas. And when we compare it with the hard currency, when we compare it to the hard currency now, it's also useless. But it has a future if the economy and employment improve and the government supports this sector and pays attention to it.
Yes,
so I think what he mentions here about the process. to what you said at the end of the presentation about the life cycle cost and not to make direct comparisons
Yes.
between LPG and biogas.
Yes, the important thing, Muhammad, is that the solution is a part of the community, and we having the policies, the related policies. Renewable, as you know, renewable energy is new, so it needs support. Why the ethanol project failed in Sudan? Because of the subsidies. You cannot subsidize, provide subsidies to benzene, and we will not provide subsidies to ethanol. And you want ethanol to be like successful project. It cannot, because you have to have policies. Musaddiq can explain more about the policies that are implemented in EU countries to support the grow up and of renewable energy as general. So I agree with you. Even now, if you ask me what is the cost of biogas digester now, it is like $600 US. How much in the local currency? It is really a lot of money that we cannot afford to sell. But we have to look for everything together, the whole picture. We have to look for whole picture. So some other countries having this digester with $200 US. So the problem is not in the biogas system, but in our financial system and in our economical. So as the beginning I said, the situation in Sudan, we're having fragile economic condition, and this is so that everything is challenged. But we have to think out of the box, and we have to bring the government to be part of the solution also and support any development, because at the end you are not talking about just one community. You are talking about benefit for the whole country, and at the end also it supports the government, because instead of paying hard currency to export LPG, it could be produced locally. And then if you compare it, the benefits will last for 10, 15, 25 years.
Exactly, yeah, because the lifetime of the technology is quite big, so it's quite large, similar to solar PV as an example. We have two more questions. Mujahid, his question is about the safety aspects in biogas technology because of the fact that there is bacteria in animal waste that is used in the process. So are there any safety considerations or any risk on humans due to the bacteria in the feedstock or in the system as a whole?
Maybe I didn't understand, but as you said, he means the bacteria in the, for example, in the cow dung, and
yes.
At the end, yes, the fermentation process in the digester, which is an anaerobic digestion process, is done by bacteria. So there is a fermentation process done there. So you mean, for sure, you are not meaning the risk in biogas. You mean the risk in the biofertilizer, right? So for the biofertilizer, we need to ensure that the biofertilizer has the quality that we need as a biofertilizer. So it is a just technical question. I cannot go deep more in that, but I think if you looked in any technical paper about the quality of the bio slurry or biofertilizer from the biogas unit, considering what you said, you can find the answer. I'm sorry. And Muhammad, I just want to share with you I think you have the photo in the screen.
Not yet. You need to close or minimize the PowerPoint window. Yeah, and then open another file. Yeah.
Is it clear now?
No, still no.
Okay, maybe I want to share.
Yeah, you need to click share screen. Okay. I think.
Yeah, share screen now. Do you have it?
No, we don't have it yet. Maybe try to close the the share screen button, and then okay, yeah, okay, now you can open, yes, the photo.
Is it clear?
Yes, yeah, we can see now, yeah.
Yeah.
Covered
So
lagoon
these are
process.
the covered lagoon, yeah. Yeah, for chicken processing residues and also for wastewater treatment. So normally this is the case. They use it like this. For example, in the orange one, this is in China, I think. This is used for at wastewater plant. So big lagoons, tens of meters, but you have the same process, anaerobic digestion. And mostly the biogas produced, because here a lot of quantity of wastewater, the biogas produced tend to be electricity. Another photo also I want to share with you for commercial. This is from Germany, and is it in the screen, Mohammed?
Yes, yeah, we can see now your screen. Yes.
Yes. Okay. So this is digester. We call it. It is anaerobic digestion. But as I told you, if the country is very cold, like in Germany, for example, okay, and in Sudan, there are big difference. So you want to provide the environment for the fermentation. So for example, this digester is also anaerobic digestion, but they are using because it is big. It is 1,000 cubic meter. They are using feedstock is coming from where? Actually, it is a project of one entrepreneur. He was working as accountant in a bank, agriculture bank. He just quit and took finance from the bank and built this 1,000 cubic meter. And he's running the whole project with 3 people because it is all computerized. So the case is what? The feedstock is coming from the farms. So the sludge you can see in the photo above in the left, this is from the farmers. The farmers providing the sludge, which is mix of cow dung and pigs dung, and also what you call it, agricultural residues. They bring to the farm, okay, to the biogas plant. He does the fermentation. He produces biogas. The biogas is used in compound and heat power unit to produce heat and electricity for families, so distribute to the household. And what is the benefit for the farmers? They come and take the fertilizer. So it is a win-win situation. Okay, it's a win-win situation. He don't buy the feedstock, and he don't use the fertilizer. The one who provides the feedstock is the one who is taking the fertilizer. So they take the fertilizer back to their farm and they use it for increasing crop yields. So here they use a cluster heating. So they use heating and they're using mixing to ensure the mixing of the what you call it, the feedstock inside the digester, because it is very big. And every year after that he was building a new digester, so until he had 3,000 cubic meter digesters. And we asked him, is this beneficial for you? And he said, yes, I'm living with my life on this project, and I'm living on this project. And they are just 3 people running all this with his dog and computer system. So it is not difficult, but at the end we have to have requirements for successful program.
Exactly. True. We have one last question from Nohal Badawi. Hello everyone, thanks Dr. Hazir for this nice presentation. My question is there any biogas project used to generate electricity in Sudan? And if not, what is the possibility of having such a power plant? Not necessarily a national one, run by the private sector, for example. She also says that she did her master's degree in the UK, and she has seen similar projects. They cooperate with suppliers such as restaurants to ensure continuous supply for power generation, basically.
Okay, thanks, Noha, for your comment and for your question. So far in Sudan, there is no any project of biogas to produce electricity. In 2000, Engineer Faisal Rahimahullah established 2 biogas units. Each one was 25 cubic meter. This was in Al Khalifa Al Burai in North Kordofan. They were using the waste from the toilets, okay, and from this one they were producing biogas, and the biogas used to produce electricity. Okay, this what they call it khalwa. Okay, and part of biogas for the electricity just for a few hours at night, and the rest is for cooking, because they are having many people at that area, and kids are reading, learning and memorizing Quran. So this is the only project, and this one is not working now because just of social problems, not for technical problem, and it's not working. But so far, I didn't see any other biogas project producing electricity in Sudan. We were talking with Dal Group, the agriculture one, because they have a very big feed lot, and they wanted to have more cows in that livestock in that area, and they were expending a lot of money in this diesel because they're having this pivot system for irrigation. And but that time, because there is no capacity, no company has the capacity to build big projects in Sudan, so it should be done with like partnership with other companies which is mature, because private sector, the main thing for private sector is to ensure that the money expended is going to come back. So and also the capacity of companies in Sudan to produce biogas in larger scale, there is no capacity. So it should be done with partnership with other company from out the country. But the potential is there. The potential is there. And when you mentioned the project, you call what you call, Muhammad? She said the restaurant, right? I know also in UK. Yeah, in UK, I think for the new projects for like chicken farms or livestock farm, if they want to have a new one, the policy of the government is that to ensure that this farm is going to use to be self-energy, like the waste they are going to produce is the waste is going to produce their electricity. So they are not pressure on the national grid of electricity. And if we done this in Sudan, it will work, because Sudan now, the subsidies in the diesel and the petroleum products is not showing the real cost of these fuels. Okay, and so any other or new solution will be like it is high cost. So we need to think of that. I hope I answered your question.
Yes. Yeah.
And Mohammed, I will be pleased to also people having my email. So like Noha or anyone else want to talk or to discuss with me or to call me to see, because I work with different stakeholders. So if they're having any more question or information want to have it, I can share with them.
Yes, definitely. And actually, this is a announcement for the attendees. Dr. Hazir recently published an article with in our blog. It was a research paper about biodiesel production from crude jatropha oil. Very interesting paper. So it's in our blog. Everyone can check it out. I'm gonna put the link right now. I guess since there are no more questions and it's almost 2 hours now, I think we can conclude. So thank you very much, Dr. Hazir. We really appreciate the time and the effort you put. I'm very glad to have you give us this webinar. And hopefully, inshallah, we can see you in the future as well in other webinars, because I know you have expertise in other areas. Actually, I had a lot of questions I wanted to ask, but maybe you can postpone them to some other time. especially to learn from your experience working with different government entities on renewable energy and institutional structure. I know you have a lot of experience in that and a lot of interesting ideas. So perhaps, inshallah, we could learn more about those in another webinar. So thank you very much, and thank you everyone for your attendance. I posted a link to a survey that we have to evaluate this webinar, and also to let us know what topics you would be more interested in learning more about through Clean Energy for Africa. So kindly take the survey. It's 1 or 2 minutes in SurveyMonkey. And also be sure to join our mailing list in the website, cleanenergyforafrica.org, so that you can be updated immediately about any other events or activities that we are hosting. So thank you everyone. And by the way, this lecture has been recorded, so I'm going to upload the video on YouTube, inshallah, tonight or tomorrow, and we will put it in our Facebook page, LinkedIn, and so that you could share it with other people. Thank you everyone, and have a good night. Assalamu alaikum.